Hello and welcome to this channel. In this video, we are going to create a weather application with a Python backend. We are going to use PythonAnywhere Backend to create our backend site. This is the application we are going to create. We simply enter a city and we click on Fetch Weather, and we are going to get the weather for that city. So let's see how it works in the background. First, we have our application on the device. And then we have our backend PythonAnywhere, and then we have our weather API. First, we are going to enter a city name and click on the button. The request goes to the backend, and the backend is going to request the weather for that city from the API. Next, the weather condition is returned to the backend, and then the backend is going to send it back to the device and the application displays the weather condition. So you may ask, why don't we request the weather directly from phone and we use the weather API directly and request the weather for that city directly from the phone? We could directly call the weather API to fetch data without the need for the intermediate backend. But there are some reasons why we might want to include a backend in our architecture. One is abstraction and decoupling. Having a backend layer allows you to isolate the client application from the direct interaction with the third-party APIs. This is useful if you ever need to switch to a different weather API, or if the API itself undergoes significant changes. You can manage these changes at the backend without needing to update or redeploy your application. The second one is data processing. Your backend can be used to process or aggregate data before sending it to the client. In this case, the backend can be used to filter, format, or transform the weather data from the weather API before sending it to the Flutter application. Next one is rate limiting. Some APIs, they have limitations on the number of requests if you use the free plan. By using a backend, you can cache responses and manage the number of requests you are making to the third-party APIs. And last one is security. Sensitive data like API keys should not be stored in the client-side code where they can be discovered using reverse engineering methods. Instead, they can be securely stored on the server side. For this application, we are going to use Flask on the backend side. So what is Flask? Basically, Flask sits on the backend and manages the requests that are coming to the server. It's a very intuitive and easy to use framework. We can go through this example to understand it better. In our code, we have @app.root and then we have the path. In the first case, we have /user/username. So whenever the user enters the URL address of your website and then /user/the username, for example, x1234. When the user enters, the request comes to the backend and it looks for a match because we have 3 routes here. It matches the first one, so it's going through the first route and it's going to execute the function that is associated with the first route. If we have another route, for example, /post/post ID. So if our user enters the address of the backend /post/234, for example, the request comes in and Flask is going to manage the request and matches the request to any of the routes here. Next, let's look at the PythonAnywhere.com. Why did I choose this one as a backend for this video? Because it is using Python and you can use this website very intuitively, just like you use your terminal or CMD, and you can manage your files in a graphical way. So it's very beginner friendly. So you can start with this website and as you learn, you can move to other platforms. This website can handle small to medium requests for your application. In addition to the free plan, they have some other plans as well. I've been using the hacker plans for $5 per month for a long time now. And for start, you can use this plan or you can go for the free plan as well. But in the free plan, I'm not sure if you can get a web app or not, because we are going to use the web app. And if you are interested, I leave a link in the video description. You can use it to sign up for any plan on PythonAnywhere.com. So after you sign up, you have this dashboard. On top, you have consoles. Inside the consoles, you can open a Bash console or MySQL console, because this website also offers databases as well. So when you click on Bash, for example, this section shows any consoles you have open already. So I have one. If you click on a console, a new one or the one that is opened already, you go to a page that is very similar to terminal or CMD, and you can type your commands. For example, install Flask or install any other library. Next one is files. In this section, you can manage your files using graphical user interface. So you can select them, you can go inside a folder, and if it is a text file or Python file, you can go inside it and you can change the content as well. Next tab is web. Inside the web, you can manage your web apps. You can create your web app, and then inside the web app, you can see the traffic, you can reload it, you can manage the code, the source code, the working directory, you can manage the virtual environment, and you can see the logs on the server as well. The tasks shows you all the tasks that you have available. You can create tasks, for example, a piece of code that repeatedly executes at certain interval of time. You can, for example, write a script to back up your database, and you can run it every day on specific time, and this is done automatically. And databases shows you your available databases. It has MySQL and Postgres databases. For this weather application, we first need to go to consoles. And we need to create a new console, or if you have one open, you can use it to start the console. Here you can create a new virtual environment, but if you are not familiar with a virtual environment in Python, that's okay. You can directly go ahead and install all the libraries that we need. So we need to install Flask and request libraries. So we are going to say pip install Flask requests, and you need to wait so that it is installed on your environment. Next, we are going to the web section. So from here, we are going to select web. So in here, we are going to create a new web app by clicking on add a new web app. And then we can select the first option, that's okay. Next, we are going to select which framework we are going to use. So we are going to select Flask. And then which version, we are going to select 3.8 or any other version that you have installed or used in your console. And this is going to be a path to your Python files. So here it mentions enter a path for a Python file you wish to use to hold your Flask app. So this is fine. We are going to click next, and your web app is ready. Now we go to files. Inside files, you can see on the left we have directories. And in the directory, there is a new directory called My Site. And inside My Site, if you click on it, we are going to go inside the directory and we are going to see flaskapp.py. This was created when we created a new web app. Let's go back to web section. In the web section, if you go down a bit, you can see inside the code section, we have WSGI configuration file. Here you click on this file and you come to this page, which is inside the Python file for WSGI, which is a configuration for your server. In this page, we need to point the Python Anywhere to your web app. So this is here from Flask app, import app as application. So this one here should match your Flask app application. So in this case, it is Flask_app. So let's go to Files and let's go to My Site. Here you can see the name is Flask_app. Now inside this file, we are going to write what happens when the request comes to the server. First, we are going to import Flask and JSONify, and then we are going to import requests. We initialize the app, and then we specify the route. We specify /weather/city. And when we put city inside these brackets, we mentioned that we don't want the exact word of city, but anything in this place is going to be stored in the city variable. For example, /weather/London. London is going to be stored inside our city variable. So if this is the right route, we have a function that is going to be executed. And the function gets the city as a parameter. First, we will have our API key and base URL as a variable. And then we have the parameters as a dictionary. We do this because some city names, like New York, there are 2 words with space in between. And this needs to be encoded, needs to be fixed before we request from the server, because we cannot use space inside a URL. But otherwise, you can directly write this base URL / your API key and then the city. But this way, it's going to handle the space between the city name as well for us. Next, we are going to use the requests library and get the base URL and then parameters. And we are going to store it in response variable. And response.json is going to return the response in a JSON format. Now, inside the JSON format, this is what we extract. There are lots of information that the Weather API provides, but we are going to extract some of it. For example, we are going to extract the city name, the temperature, and the temperature that is received from the API is in Kelvin. So we need to convert it to Celsius, or if you want to convert it to Fahrenheit, you can do this here. We are going to get the description, the humidity, and the visibility. And then we are going to return the weather data using JSONify. This is going to create a format that is understandable by the Flutter application. Because notice that here we are using the Python language. And in our application, we are using the Flutter and Dart programming language. So they don't understand each other, but this JSON, it's like this format. This is the format that most programming languages understand. So if we format the response in a JSON way, the Flutter is also going to understand it. And then we have some error handling using the exception at the end. So this is all the code that we need for our server on the Flask side. We also need a weather API. So you can go to openweathermap.org. In here, you can create an account and you can get an API key. When you first create an API key, it takes some time, like 1 hour or 2 hours to activate your API key. So you need to copy this key because we are going to use it later. Now inside our Android Studio, first inside the pubspec.yaml, you need to add HTTP package, because using this HTTP package, we are going to send requests to our backend and receive the response. Next, inside the main, we are going to import the material, the services, HTTP as HTTP, and we are going to need Dart convert. Inside the build function of the myApp class, we have defined some themes. For instance, we have the theme for text, we have the theme for border. So for the first one, the theme is text theme, because we are going to use this theme to decorate our widgets, like buttons, like card or text field, and so on. So we have text theme, we have display large, and we have body large. And we have some style for each one. Next, we have input decoration theme. We have specified some border radius and some fill color and focused border, border side, and so on. Next, we have button theme where we can select the button color and text theme. And also we can customize the shape. Next, we have our class, my home page. Inside here, we are going to define a string called city. And we are going to define weather data, which is type of map string and dynamic. Next, we are going to create our function fetch weather. Inside here, we use HTTP package to request weather for a city. We have await because it is asynchronous request, so the function is also async. Inside the http.get, we are going to enter the URL for our backend /weather/city, and we check for response. If the response is 200, we set state response.body, we decode this one and we put it in the weather data variable. Otherwise, we are going to print an error. Inside the build function, we have all the elements. As you can see, we have text box, we have button, and we have a card. Inside the text field, we have unchanged value, and then we have city equals to value. This means that when the user enters city name inside the text field, it's going to be stored in value, and then it is going to be transferred to the city because we need to save this city so that we can request the weather for that city. Next, we have some decorations, and then we have a size box, and then we have elevated button. Inside the button, we have onPressed, and we mentioned the name of the function that we created, fetch weather. And then we have some style for the button, and then we have size box, and we have the card. Inside the card, we are going to display all the weather data that we received from the server. So we add the card widget with elevation of 4. We specify the shape, and then we are going to create a column. Inside the column, we have the text widget for the name of the city, the temperature, the description, the humidity, and the visibility. These are taken from weather data that we received from the server. And that's all for this application. So it's very easy to use a Python backend for your application. You just need to call your web app and use Flask to direct your request, and then you receive your data, and then you display the data on the application. So I hope this was helpful. Thanks for watching. I will see you in the next video.